Hi, I'm Alistair. I'm a games designer, and in this video I'd like to teach you how to use some software called Asterisk, PBX, which runs on a Raspberry Pi, and to create a playful telephone network. So what's a playful telephone network? Well, it lets you use ordinary telephone handsets like these two here, alongside other props such as a maglock or anything else, to create kind of fun, playful interactions of the kind you might find in an escape room or something like that. So let me give you an example of what you can do with the system. On my laptop, which is over here, what I'm going to do to start with is dial the extension number associated with one of the handsets on the network. And when I place that call, it's going to create that handset to ring, like that. I can now answer the phone, and I'm now connected through the network. Everything I say into the microphone comes out of the speaker of my laptop, and likewise everything I say into my laptop speaker comes out the earpiece here. So that's just like placing a telephone call through the normal phone network, but it's done internally between these two devices. And you can do that between physical handsets on the network as well. So if I dial the number, I'm doing this upside down, so just want to make sure I dial the right number. I think that's right. So you can have any number of physical handsets as well, and that's just connecting now. So in a moment, this handset here should ring. There we go. And these two handsets are now connected. So when I speak into one, I hear it through the other, just as you would a normal telephone call. Okay, so that's how you create actual devices that can be connected and place calls to each other. What you can also do is you can create an infinite number of virtual extensions as well. And rather than being attached to a handset like this, they can run scripts or play messages or all sorts of other things as well. So perhaps the easiest example I can show you is just an extension which, when it's called, plays back a sound file, much like an answer machine would do. So we'll just hold this up to the microphone.
This is a secret message which I recorded earlier.
Okay. Not very secret, I know, but that's all I could think of to say at the time. And you can create quite complex sort of telephone tree structures as well. So rather than just being played a straightforward message that's the same every time, you can set through a set of menu options. So, you know, press 1 for this, 2 for this, like those kind of automated dialing lines that you probably have to call if you want to get through to some sort of customer service center or something like that. So you can create quite complicated logic. I can tell that you're still not wowed though, so let me carry on and show you some other things you can do. Over here, this is a Wemos D1. It's very, very similar to an Arduino Uno. The only difference is that it has built-in Wi-Fi. That's not the only difference, that's the main difference. And that's the reason why I'm using it in this case. It's obviously running off a battery, and it is connected to the server, the Asterisk server, which is running on the Raspberry Pi there. Now what I can do with this is any code that's running on here can trigger an inbound call to the network as well. So let me press this button here, and that is going to cause this telephone to ring, and it's going to deliver a message. So I will now play it.
This is the dynamic message generated by text-to-speech software. To release the maglock, you should dial 5551234.
Okay, so hopefully you picked that, but just in case you didn't, that message was generated using text-to-speech software. So what that means is that the code that is running on your Arduino device or your Wemos or whatever it is, that can actually deliver a message which is variable depending on any sort of input you want. So maybe you've set some dials to a particular value, you've pressed a button a certain number of times, whatever it is, that can then deliver that message through Asterisk and get it to be spoken out via text-to-speech on the receiving handset. Okay, now that message actually told me to dial a number to release the maglock as well. So let me now try that. And hopefully I remember it correctly. I think the number was 555 1 2 3 4.
Releasing lock. 3, 2, 1.
crikey, that gets me every time. So there you go, that's another example. In that case, that was a virtual extension which answered the call, and when it did, it ran a script on the Raspberry Pi which controlled one of the GPIO pins to activate this relay. The relay cut power to the maglock, and the maglock fell off onto my table, making a little bit of a dent. And there's lots of other examples of things you can do with this same sort of hardware as well. You can call external services like voice recognition services, for example, to detect what the player said and then follow different conditional logic branches and things like that. You can record phone calls and play back snippets of them later. So there's lots and lots of exciting things, and I want to show you how to do them. So there's quite a bit of setup involved. It's not difficult, it doesn't require hardware modification, but there's just a couple of steps to go through. So what I'm going to do is divide this into chunks, and in this video I'm just going to show you how to set up the basic phone network, and then I'm going to make subsequent videos that's going to show you how to add on each of those features which I've shown you. So let me start by talking you through the hardware that I've got on the table here. So to start with, I've got two telephone handsets. And these are completely normal handsets that were designed to be used on the British telephone network. So these are BT handsets. They're both modern telephones, and if I plug them into my phone socket in the wall, they would work absolutely normally. They've not been modified at all. This one is obviously designed to look like an old-fashioned rotary dial handset, but it's actually a modern handset that uses tone dialing. So each of the keys here will create a DTMF dialing tone on the line. This one's obviously a more modern style, and it's important that you do have a phone that is designed to work like that. If you've got one of the genuine old-fashioned phones that uses a series of pulses, what you'll need to do is to first get a converter for that to generate tones instead. It's possible to get them online. You could probably make one yourself if you're handy with an Arduino or something like that as well. But it does need to generate tones to work with the system. Now, in a previous video I made, I used a UK telephone handset, and I got lots of comments from people all around the world, which was fantastic. And what I found out is that telephones around the world are all very different. So just to explain, this handset here, this has what is a BT431 socket. Now that is the normal phone socket that you get on telephones in the UK. This one here, however, this has an RJ11 socket, which you can see looks slightly different. However, I believe that that is the standard used in many other countries around the world. If, like me, you're in the UK and you have a BT style socket, the first thing you're going to want to do is to get an adapter like that. This is a purely mechanical adapter. It costs about 99p, and you plug it into the end, and that's going to convert your 431 style plug into an RJ11 plug there. Okay, so now that you've got an RJ11 plug, let me just slot that in there. The next piece of hardware I've got here is this little grey box here. Now this is a Linksys PAP2T, and it is an analog telephone adapter. What this does is it lets you take a regular telephone handset designed for use on just the public phone network, which is what both of these two are, and it sort of converts it into a VoIP IP phone or something like that. So it's going to take the tone signals that are produced on the line by these handsets, and it's going to translate them into something that can be used across a network to an IP phone server. And it's also going to handle the incoming calls and let the phones ring and things like that as well. Now this particular unit has got space for two phone sockets here. It then has an Ethernet socket and a power socket at the end. You can get ones that have more ports as well, but the one I've got, 2 is just fine. I think this model might have been replaced by a newer model now, but I'll put a link to where I got them. You can still get them on eBay and things like that, and they cost about £15–20. This Ethernet wire that comes out the back of here, this is plugged into my network hub. as is the Raspberry Pi over here. So these are connected to the same network. The Raspberry Pi, on this side, I've got 2 of the GPIO pins broken out onto the board here. Now, this is actually quite straightforward. It just looks a little bit more complicated than it would be normally. You might have seen in my previous videos I've used Arduinos to control relay modules like this to activate maglocks. The Raspberry Pi is doing the same job as that. The only difference is that the Raspberry Pi input and output pins operate at 3.3 volt logic, whereas an Arduino Uno or a Nano or Mega runs at 5 volt logic. So what that means is an Arduino can control one of these relay modules directly. The Raspberry Pi, however, you need to have this kind of intermediary state in the middle. So that's what I've got here. So what I've got here is a MOSFET, and when the Raspberry Pi sends a high signal here, which is 3.3 volts, that's going to activate the MOSFET, which is going to allow this 5 volt supply here to go to the relay. So this relay is running at 5 volts. Oops. So we've got the Raspberry Pi at 3.3 volts, the relay at 5 volts, and finally we've got a 12 volt supply here, which is going to go to the maglock. And so that's actually all the hardware involved. The only other thing, like I say, I've got a WeMOS D1. You can also get WeMOS minis, you can get ESP32s, ESP86s, and you can use Arduinos, basic Arduinos that have either a Wi-Fi shield or an Ethernet shield attached to them as well. You just need something that's going to be able to connect to the same network that these other devices are, and that can run Arduino code, and that's going to trigger incoming or receive outgoing calls as well. And now just let me show you that hardware setup as laid out in a diagram in Fritzing. So here we've got the whole network. We've got the 2 telephone handsets over this side here, and they are connected to the line in ports on the PAP2T. That in turn has got an Ethernet connection here, which is going to my network hub here. I've also got my PC plugged into the network hub via the Ethernet, and I'm going to use my PC both as a soft phone client. So that was what enabled me to place that call to make the handsets ring and to speak via my PC microphone and things like that. So this can actually become an extension on the network itself and to have incoming and outgoing calls. But I'm also going to use my PC to manage the Raspberry Pi as well. So rather than logging on directly to the Raspberry Pi, plugging in a keyboard and a monitor and things like that, I'm going to connect remotely using software called Putty to run command lines on there. So this is also going to be my kind of management console to actually run the server overall as well. Over here, this was the WeMOS device I was using. So this is what's going to allow you to have other sort of triggers, if you want, that are going to be able to make calls come into the network and things like that. So I'm using a WeMOS because it's got Wi-Fi built on, but you could use an Arduino Uno with a Wi-Fi shield, or you could have an Ethernet shield as well with a wired connection into the network hub there. There's sort of several different options there as to how you might want to have devices that trigger sort of telephone interactions. And here I've got the Raspberry Pi itself. So this is running the Asterisk software. So this is acting as the main server for all the calls that are going to be connected between these devices. And on this side of it as well, we've also got that relay which it's controlling as well. So I'll explain this in more detail in the video when I talk about this, but what's basically happening here, I've got a ground pin here connected to the header of the Raspberry Pi. That's going to this rail on the breadboard. And I've also got one of the GPIO pins. I've got GPIO 18. And that is going to the gate pin of a MOSFET here. So a MOSFET is like an electrical switch, And when a voltage is applied at the gate, so in this case it's going to be 3.3 volts at the gate, because that's what the Raspberry Pi will give out, that is going to allow then current to flow between the source and the drain pins, which are the other two pins on the MOSFET. So what we've got here, so the gate has also got a 10 kilo ohm resistor here. That's going to pull the gate down to ground when there is no signal being detected from the Raspberry Pi. So when nothing happens, the gate is pulled down to ground, and that means that no current is going to flow between drain and source. If no current is flowing, what that means is that the signal line, which is here, this is not connected through to ground, and this remains high. The relay module here, in common with most relay modules, is what's called an active low module. So its default state is going to be high at this signal, and to energize the relay, what we want to do is to pull it to ground instead. We want to send a low signal. So when no signal is here, the gate is pulled down to ground, no current flows, this remains high. However, when the Raspberry Pi sends a high signal onto this pin 18, so we've now got 3.3 volts at the gate, and this is going to allow current to flow from this signal line here through drain and source down to ground. So this is opened the relay. Now this has pulled this signal line down to ground, and on the load side what that means is that that is going to make the relay here become either disconnected or connected to the 12 volt supply which we've got coming in here. So that's what's going to activate or deactivate the Madlock. I'll go through that again in more detail when I actually get onto the video which is concerned with activating props, but that's an overview of how it happens. And that is the whole network. So that's pretty much all there is for hardware. In the next video I'm going to look at actually how to set up the software itself, how to install and configure Asterisk on the Raspberry Pi, and how to get your extensions set up so you can actually start making and receiving calls.